All right, so the first part of this problem to calculate delta G standard is a review of chapter 15. I'm going to do the products minus reactants thing, which my products are Cl2, and actually I have two products, but it took me a second to notice. Cl3 also is a product. So there we go. Those both go in together. And then minus the reactant, PCl5, to get the delta G. And I get positive 39. My units are kilojoules per mole. All right, so that was chapter 15. Now, chapter 16, I can convert this to an equilibrium constant, a K. And there's an equation for that. K is the exponential of negative delta G standard over RT. So negative 39 kilojoules per mole. R, I need to convert that to kilojoules per mole if I'm going to leave my delta G in kilojoules per mole, or I could convert the delta G to joules. I just need those units to cancel. And then the 298 didn't actually say that in the problem, but I'm just going to assume that's what they meant. Oops. All right, so I'm going to put that really carefully in my calculator, and you can't quite see what I'm going to do here. It's off screen, but the exponential function, I'm just going to use lots of parentheses. So then negative 39 divided by, and then start another parentheses, so I get all the denominator put together, and then two parentheses to end. And I went ahead and converted it to scientific notation because it's pretty small, but 1.46 times 10 to the negative 7th. That's my K. Okay, now the next part is asking me to calculate a delta G, not standard. And the reason it's not standard is because for gases, standard means 1 atmosphere, and these are not 1 atmosphere. So I have this other equation where I use the delta G standard, 39, that I just got in the previous one, times RT natural log of Q. Again, I want to convert that R to kilojoules per mole so that the kilojoules will add up, the 298 Kelvin, and then I need the natural log of Q. Q is just like an equilibrium constant, but it doesn't have to be equilibrium concentrations. I don't need an ice table to get equilibrium. I just plug in the numbers I have. So products on top, Cl2 and PCl3, so that's the 0.4 and the 0.27 atmospheres. And then the PCl5 on the bottom, 0.0029 atmospheres. That'll be my Q. So put that all in my calculator. And I get 37.2 for my Q. Take the natural log of that, multiply by the 298, multiply by the R converted to kilojoules, 0.008314. And for that whole part, I got 8.9. The units, the Kelvin would cancel, so my units would just be kilojoules per mole. Add that on to my delta G standard to 39 from before, and I'll get my answer, which to 2 sig figs is 48. And then the units would be kilojoules per mole.